The truth is, the only reason I started Fog Creek Software is because I kept trying to look for a great place to work in New York that treated software developers well, and I just couldn't find one to work at. So in desperation, I finally made one. I mean, I would go to parties and I'd meet somebody and I'd be like, hey, what do you do? I'm a programmer. Oh, me too. And they'd say, do you know any good companies to work for in New York? And I'd say, no. Everywhere I looked, I saw companies that were having trouble recruiting programmers and not treating programmers well, and they didn't put these two things together. They didn't realize that if they treated programmers well, it would be easy for them to recruit programmers. And so I decided that that was an opportunity that I had to fill, and I just needed a place to work that I liked. So I started Fog Creek. I started writing a website called Joel on Software in an attempt to kind of put down on paper some of the things that I had learned over the course of my career in how to develop software successfully. And part of my mission in life and part of the goal of Fog Creek Software as a company is to teach you how to be awesome and to let you learn how to develop software successfully using some of these same methods and some of these basic steps that make sense, they're logical, they're easy to follow, and when you do them, you're going to be more successful in software development. Think about what a programmer is doing. Every single line of code that a programmer writes involves several decisions. You have to decide what line of code to write, and then you have to decide, if you're calling a function, what are going to be the arguments to all those parameters. If it's an if statement, that's a decision. And every single one of these decisions is sometimes a judgment call, and the smarter you are, the better the judgment call is going to be, and the more likely that code is to work. There's an aria in Mozart's Magic Flute called The Queen of the Night, and it's sung by a soprano who has to, I think twice, hit this high note called F6. The average soprano cannot sing this song, cannot do The Queen of the Night at all, ever. And I think the same thing happens in software. You want to hire programmers that can reach the high notes, that can do the really excellent achievements, and that come up with sort of great ideas, that come up with great designs that maybe the average programmers would never come up with in a million years. Okay, so we're about to start our campus recruiting season for the fall, with the goal of hiring another 6 interns for next summer. Another couple of co-ops, at least. We could probably have as many as 4 for, when's the co-op term? June? January, right? You want to have as aggressive an internship program as you possibly can. One of the things that we noticed very early on is that when you're recruiting for internships, for summer internships, the audience you're recruiting from is all college juniors majoring in computer science. And they're all applying for summer internships. Whereas when you are recruiting for a full-time job, the audience you're recruiting from are people who hate their job and people who got fired from their job. So the college, when we look at the resumes from college juniors applying for internships, honestly, they're much, much higher quality than the average resume from somebody full-time applying for a job. There are a couple of reasons for this, but the bottom line is that the really, really smart candidates don't apply for a lot of jobs in their life. I mean, some of the best programmers that I know have applied for, maybe 7 jobs in their entire life, including the ones they took and the ones they didn't take. When you get a resume, the easiest thing to do is take a piece of scrap paper, write PBECSJ, and its column headings, and then go through the resume looking for those 6 things, the resume and the cover letter, looking for those 6 things, and if you find them, check them off. So I'll go over what they are, roughly what the categories are. P is passion, and that's like passion for software development tasks, like people that love programming, people that love computers, or people that just like gadgets or stuff like that. Brains, we just have these like little numbers for that. But brains is, you all know what a brainiac is, right? These are the people that we make fun of in school. Here's some examples. They have high GPAs. We do actually want people to be able to communicate well, so the quality of their writing, both in their cover letter and their resume in English writing, is pretty important to us. Okay, so C is creativity and flair. What we're looking for is, were you being creative with your application in some way? And almost all of you were. And it's either, this is a custom cover letter for Fog Creek. It says something about Fog Creek or Joel on Software, or even New York City. Even it's like, when I heard there was a software company in New York, I was really excited. It's probably worth more of our time to pursue the people that think that Fog Creek is special in some way and are likely to come work for us. So that's creativity. And flair is like literally, I think probably 3/4 of you when you applied to work at Fog Creek did something on your cover letter that was like either funny or witty or unique or individualistic or just like not your standard cover letter. S is for screening. And so what you're going to do is look through the resume for institutions that you know are selective and that have screened people and that don't take everybody that applies to them, whatever the institution may be. The easiest thing is, so obviously schools that they go to, and that means selective schools will get you this point because we know that somebody somewhere has evaluated you in some fashion. Cool. Over the years, the last couple of years, we've been kind of lax about this J thing, junior in college. Basically, our ideal intern is a junior for several reasons. One is you can make them an offer at the end of the summer, and they're not going to have any other internships. They're going to get in the way and make them want to go work somewhere else. The people that did internships as juniors are much more likely to turn out as full-time developers, so that's why we give them sort of substantial preference. Cool, that's it. Thanks.
Resume review is the first section of our difficult process of getting hired, and we try to make it as democratic as possible. This person went to Stanford. That's an immediate selective plus. This candidate says that they're sick of working for the giant orgs, larger companies, and they'd like to come work for a place like Fog Creek. This indicates that they know who our company is, they've read a little bit about on our website, and I will give them a creative for that. This cover letter is also well written, so they score an E. So that's 3 letters right off the bat that this candidate got. So here this person has competed in an HP programming competition. This is a good sign. This is this is somebody who's going out of their way to practice their own computer science, compete against others. And the GPA is 3.8 at Stanford, which qualifies for brains. So this is a great example of a candidate. This person just got all 6 letters, and they'll certainly be phone screened.
We don't get a lot of information out of the cover letters and the resumes. The format is not ideal for applying for a programming job. It doesn't really show, there's nothing on a resume that shows that you know how to program or not. And so the best we can do really is try to guess whether it's worth going further with this person or not based on the information in the resume.
This is a much shorter cover letter, which doesn't really indicate that they know anything about the company. It's a very standard cover letter, which could have really been sent to any company, and doesn't convey that Fog Creek means anything different than any other company to this person, so I cannot give them a creative. It is well written, so so far this person gets an E for English. Now this is an example of somebody who did not originally give us their GPA, and our automated bot emailed them and said, please give us the GPA, and they came back and said their GPA is 2.86, so that's not that's not indication of a B in this case. This college is also not on our selective list. This person is a junior. And this person also has some additional typos in their resume that describes their goals and their research history. This is usually a very bad sign. If somebody has typos in their resume, they haven't gone through and checked some of the most basic things. This person also already has 3 X's, so that's going to be a ding for me. Typically, we need programmers who are going to be communicating with customers. We need them to be able to communicate their ideas, to spec their ideas, and having typos in your own resume is a very bad sign.
If you have 5 or 6 letters, you're likely to get to the next stage, which is the phone interview. The phone interview consists of a developer calling you up. We'll schedule a time, usually after work, and asking you some programming problems that are conducive to telephone conversation. So not quite as much detail, a little bit more like maybe conversation about algorithms, conversation about data structures, just sort of like how would you build this thing in code. And the developer will tend to, the person conducting the interview will tend to drill down a lot in certain areas just to see if the candidate is really highly technical.
Hi, this is Benjamin at Fog Creek Software. I kind of want to do this in 3 parts. First, I want to give you a chance to kind of talk about some recent stuff you've done that's really exciting, and then work through a bit of a design question together, and then give you a chance to ask me any questions you've got about Fog Creek. And the fellow I interviewed today was a senior developer. He's been out of college for 10 years and had experience working at Microsoft and tablet PC, and on live search, and also had a fair amount of experience actually working at NASA.
I was the stuff that I worked on was for the ovens that were supposed to heat up the soil samples that the robotic arm dug out of the dirt and analyzed them for presence of various chemicals. But unfortunately the guidance system on the spacecraft didn't function well enough to get it to that stage where you'd ever deploy the robotic arm and start digging. So that didn't work. But somewhere on Mars, there's bits of my code like.
Well, I mean, that's pretty impressive. I have my name on a satellite, if I recall correctly, but that's about it.
Oh, cool.
We had talked about tablet PC, about Newtons, about Palm, about live search, about converting web applications from C++ to ASP.NET, about whether Cocoa was really the next big thing or whether it's just really overhyped.
The best way to do a phone screen is to pick a very, very technical topic to talk about, a very programming-related topic that doesn't require writing code. It doesn't require a lot of specific knowledge. Like, you don't want to ask people to remember the orders of the arguments to a function in the function library. You really just want to say something like, what would be a good data structure to use for a spreadsheet? What would be a good data structure to use for a word processor? How would you write a program that generated Sudoku puzzles? That kind of thing. You want to have a conversation which can be done strictly in English conversation, just to get an idea.
Well, are you okay moving on to the design question?
Sure.
Okay. All right, so I kind of want to just talk through this, but basically, so you're a programmer. One of the things that we basically live in is our text editors, right? So it's really important that all the operations that we do are really fast, but when you start to really think about what you do, you start realizing you're manipulating a large amount of data and you expect it all to be really responsive. So what I kind of want to explore is how to design the in-memory data structure to handle all the text in a text editor.
Okay. Well, let's see. So you could have. For point of absurdity, you could have like just a string. Keeping track of all your text, but of course that's you said needs to be responsive. So
right.
If you have a potentially a very long document, then that could be quite, especially if you're inserting a character or something, and you have to copy all the other characters.
Right.
That you have to shift the rest of the buffer. That would be bad. So I think you'd want to have some sort of division, some sort of partitioning of the whole string. One way to do it, I guess, would be...
You're trying to judge if the person is smart. That's your goal, is to judge if the person is smart. And the interview questions that you provide are not to see if they know the answer, and it's not to see if they get the right answer or get the same answer as you would have gotten, or to see if they're brilliant and they get an answer that's even smarter than the answer you would have gotten. None of that. The whole point of the interview question is it's an excuse to have a conversation on a highly technical topic about code, which is going to give you the most opportunity to judge if you're having a conversation with a smart person or not.
If it's a text editor for programming or whatever, then typically you don't have lines that are very big, so you could use just a string for each line, I guess.
Okay.
And then you need to be able to address those lines And
I think he was a very strong hire decision. He basically gave me the correct solution in about 4 minutes instead of, say, 20. That makes it a lot more enjoyable for me, because especially, for consistency's sake, we stick to the same phone screen question a lot of the time. We got a couple we alternate in between, we keep them pretty constant. And so even with a really good candidate, it's really hard to stay interested in the question. But when you get someone who just blows through like that, it actually is pretty easy to do that. So cool. So I want to give you a chance now to ask me any questions that you have about Fog Creek.
Okay. Well, let's see. So I looked at the website, and actually there's a fair amount of transparency. You've even got like pictures of the office and everything.
Yeah.
That kind of removes a whole class of questions, which I'm sure saves you a lot of trouble. But I'm curious, what's your team makeup in the sense of like for a typical project? How many testers and developers and PMs or whatever do you have working together?
They're going to be small simply because we don't know many people. And the benefit is just that it's very easy to, we've got really friendly relationships with our QA team, which I know is a little bit unusual some places, but I'm very happy to have it. And there's really no administrative overhead.
Yeah, good. Cool, okay, well, next steps then, will you...
Yes, and next up you'll be hearing from us in probably today or tomorrow. In general, there's going to be at least kind of a remote coding interview, so it's great that you already got to work with Copilot a little bit. You're going to have a chance to work with it a lot more.
Okay.
And then if everything goes well, we'd be having you in the office for in-person interviews.
Okay, great. Well, yeah. Well, thanks a lot, and it was a lot of fun. So
Yeah.
I'll look forward to it.
All right. Thank you very much.
Have a great day. Bye.
Yep. You too. Bye-bye.
We know we're going to have some false negatives. We're going to ding people when, in fact, they may have been great. But we err on the side of that versus being too easy and possibly hiring people who are not going to be good enough. And that's far worse than losing a good candidate, because if you do hire somebody that is not going to be good enough, it's hard to fire them later on. It is, you have to go and clean up after them in the code base, or whatever responsibilities are given. They're going to go and start to not do a good enough job, and you're going to have to spend someone else's time trying to fix these things, and sort of they become a liability, which is bad.
We'll sometimes do a phone Copilot interview. We'll use Copilot, which lets us see the interviewee's computer. They run a little program. We run a little program. We're watching everything that they're doing, and we'll ask them to write a piece of code while telling us what they're thinking of. We'll ask them to write a simple function to do something fairly simple, just to see if they really are a programmer, if they get it right, if they make kind of off by one errors that give you an idea that this is somebody who's really new, a novice, or to see if they're really expert programmers.
All right, so what we're going to be coding up today is a basic spam classifier.
A spam classifier, all right.
The function that we're going to be implementing is called stir cspan, and this is actually a C string library function. If you're, I don't know how familiar you are with C.
I'm semi-familiar with it. When I want to work in it, I can go and find stuff, but you'll have to explain it to me.
Sure, yeah.
So we're not going to worry about like statistical methods, Bayesian inference, anything like that.
Right.
All we're going to do is write a function that takes in the body of the email and checks to see if any of a list of phrases that we pass it occur there at all.
The idea of this function is that it returns It takes two strings. The first one is the string that it's going to search in, and the second one is a list of delimiters. And what it does is it counts the number of characters it gives you the count of the number of characters in the string until one of those delimiters is reached.
Okay, so that's basically what it's going to look like there. We're going to pass in a string of text, a list of phrases or an array of phrases, and the number of phrases that we're passing in.
Okay.
All right, I'm going to think about this for a second.
Sure.
Okay, so I guess the first thing I should really do is determine how many delimiters are in the delimiter string, and, because that's kind of important, I suppose.
Whenever you ask somebody in an interview, whether it's in person or over the computer, over Copilot, whenever you ask somebody to write code, there's a few things you have to watch for. Number one, they're in an interview, they're going to be nervous. So you kind of have to give them a free pass on being nervous. That has no correlation to whether or not they're a good developer. And they're going to make simple, kind of stupid mistakes. Sometimes, like, they make a simple mistake, like they forget a semicolon at the end of a statement, and you kind of have to forgive that just because they're nervous. It's the interview process. They're not actually typing into a compiler. The compiler would have caught it for them. Sometimes, though, it appears that they don't know that their programming language, which they claim to be their favorite programming language, requires a semicolon at the end of every statement, and then there's obviously a problem there, and you're not going to want to hire them. So there's certain things you can give people a free pass on, very, very simple syntax, almost like typos, like, oops, I forgot to type the semicolon, which is very different than I appear not to have full control over this programming language. We tend to fluctuate between just asking people to do the code interviews in C, which we consider a lingua franca that all programmers should have learned at some point. And the truth is, C isn't used that often anymore. And so if a programmer has been working in Java and C# or in some other programming language a lot lately, it may be easier for them to do the interview in that language, and we'll expect to see a certain amount of fluency with that language because that's what they're presumably programming in every single day.
Order n times m.
The second part of the interview is the technical question, which we do using Greek Copilot, where we ask them a programming question. This is where the candidate did not do very well. The question is actually supposed to have two parts. He only got through the first part, and basically the problem wasn't his coding skills. It was his developing the actual algorithm. He really struggled on that, and I had to give him a lot of prompting to get to an optimal algorithm.
Am I missing something obvious? I feel like I'm missing something obvious.
No, it's okay. Okay, well, so we feel like we definitely need to look at each character. So we have to have at least order n. But right now, for each character in S, we're looking at every character in the delimiter list. Is there anything we could do to that delimiter list to make it so that we didn't have to look at every single character in it? My recommendation for him will be no hire, because of his inability to get to that algorithm without any prompting. So he'll get a nice email from us saying thank you for applying, but we can't offer you anything at this time.
Instead of having a list here as the value in the hash table, we could actually have the value be some sort of search tree. So, for example, for D,
I did like his code. He was very clean and meticulous about the way he coded things up. And even though he didn't fully remember C syntax and certain function names, things like that, he made sure that everything was nice and readable, and that he used coding conventions that made it clear what he was trying to accomplish. So his code wouldn't really need comments. It would just be it would be obvious what the code was doing just by reading it. So he did well with that, and he did a good job of talking through what he was thinking, even if he went down the wrong path every now and then.
I've always been interested in computers. When I was probably 5 or 6 years old, we first got a computer in our house, and I thought it was really cool. In college, I guess I turned to it because I just couldn't stand any more of the miscellaneous social sciences, and I realized I just needed something that I could work towards as a very concrete goal. And computer science really offered that. I had a really crappy programming job working for one of the university departments whose job is mostly to perpetuate itself. And supposedly I was doing research into like academic computing. I mean, I don't really even know what that is. I don't think anybody does. But I was just bored and surfing the web one day, and I found Joel on software.com. That was that. And not long after, that was probably in April or May, and not long after that, I was pretty sure that I was going to apply for that internship. So I did. I had 2 phone interviews, each one of which I thought I bombed, but then they had me come out to New York for a day. And I basically just talked until I was blue in the face from like 10 a.m. until about 6:30 p.m.
I would recommend doing at least 5 interviews before you actually hire somebody, and leave the last interview for a very, very senior manager who can make the final call, or basically sell the candidate if everybody else is already sold on them. Hey, Joseph?
Yes, nice to meet you.
Come on in. Have a seat. You don't know. Sorry that we've been going really long today.
Okay.
It's just a crazy day, I guess. I don't know, our interviews tend to go on for a while.
Well, I mean, I'm here in New York for no other reason, so I guess
You might as
that's
well.
okay.
How's it going so far?
It's been fine. You know, some have been better than others, I think. I mean, I've done as well as I can. What can I say?
Okay. What's your let's see, what's your favorite programming language?
My favorite programming language?
Yeah, I mean, I don't know if that's a good question, but why not? What's a programming language that, if I told you right now, here, let's do a test.
I really believe in using the right tool.
Okay.
So yeah, give me a scenario.
Here's the problem.
Okay.
The problem is that I've got this function. Tell me if you've ever heard this one, and stop me if you have, because I don't want you to be bored.
Sure.
But I've got this, I need to simulate a 7-sided die. When you
Okay.
throw it, it can give you a number from, I'm going to make everything really easy for you, a number between 0 and 6.
Okay.
Which is easier than if I said 1 to 7.
Mm-hmm.
And it's got to be an integer. So I need you to give me whatever programming language you choose. I'm going to call it ran 7, and it can return 0 to 6 with equal probability. Okay?
Okay.
And you have a random number generator that's really, really good, and it's called ran 5, and it returns 0, a number between 0 and 4, with equal probability, 20% chance of each one.
Okay.
And you need to use this function to implement your function ran 7. Does that make sense?
Yeah, sure.
So spend a little time, think about your strategy first before you start. Because you want to make sure that you have an algorithm that's going to do the right thing before you even start implementing it.
Right. Okay. Well, my initial reaction is we multiply ran 5 by some number, and then we take the mod 7.
Okay.
But we want it to be a number that is, there's some relative primeness going on to ensure an even distribution, or to rather ensure the same distribution that we get from ran 5, which is hopefully random.
Right. It's very hard for an interviewer to try to decide whether or not the person they're interviewing is smart or not. The needle barely moves in the course of that hour. It's really, really hard to tell. It's very, very important. There's all kinds of things I tell people when you're doing interviews. Number one, don't ask the interviewee a question that you know the answer to, or don't ask them to solve a problem that you just solved the day before, because in both of those cases, you're going to have an incredible bias towards the interviewee, the candidate who gives the same answer as you gave, or the candidate who gives the same answer as you came up with, or the candidate who gives the answer you were looking for. And that's not really what you're looking for. You're looking for smart candidates, not identical candidates to you. And so you may be brilliant, but they may be brilliant in a different way. So it's better to come up with questions that are not something that you've ever worked on before.
So we need to add it in order to even begin to gain more possibilities. That's just one way we can begin to gain more possibilities from ran 5.
Well, you can add to it, but that doesn't do anything. You have to.
No, we can add 2. Can we only count ran 5 once?
Oh, no.
Oh, right. Okay, so we can add 2 results of ran 5 together.
Okay.
And then we get some random number between 0 and 8.
Cool. With what distribution?
With an even distribution.
Feel free to.
Can I write on something?
Yeah, well, that's what this is for. Go ahead, write on the board. What are the possibilities?
Okay. So 0 plus 4. 0 plus 4. So, jeez. It's gonna be
Let
like,
me ask you a quick question.
Sure.
If you have 2 dice,
Mm-hmm.
1, 6,
Mm-hmm.
how many different ways can you roll them and get 2?
How many ways? 1.
There's only one way to get
Yes.
2.
But no, I realize the distribution.
How many different ways are there to roll them and get 7?
That's the, like 1/6 of your rolls will get 7 or something?
Well, more, right? Because
Yeah.
you could roll 1 and a 6, you could roll a 2 and a 5, you could roll a 3 and a 4, you could roll a 4 and a 3, you could roll a...
Which is exactly 1/6 of your rolls.
Yeah, so that's more, there are more different ways
Yes.
to get...
So it goes
7.
like this.
Yeah, so the minute you start just adding,
It's no
lo and
good
behold, you
because
get a
we're
normal
still
distribution because that's almost the definition of normal. So
Yeah.
normal is what happens when you add a bunch of random. Yeah, evenly distributed random numbers. But we want round 7 to be evenly distributed, so it's a good start, but not exactly.
Okay.
It's also good to keep asking the same question to all the candidates that come by, and pretty soon you'll be able to calibrate that question. If you've got a question that you ask everybody after about the 3rd, 4th person that you've asked this question, you start to know what to look for, and you start to get a real good feel for whether they're answering quickly or slowly and whether they're doing a good job or not with that particular question. Also, one more time, remember that the goal in interviewing somebody is to decide if they're smart and if they get things done. To do so, you may happen to give them a problem, and they may or may not solve that problem, but the problem is just an excuse to have a conversation. It's sort of a pretext for a conversation about programming that will let you decide if that person is smart and likely to get things done.
Call round 5. If it's equal to 4,
Yeah,
call it again.
okay.
Okay?
Or while it's equal to 4.
Yeah,
Well,
well,
it might be 4 several times.
yes, exactly, because it's going to be
Yeah,
a loop.
and now we've reduced it to a number between 0 and 3.
3.
With equal probability.
Yes.
Cool, and now we have 2 bits of randomness, right?
Right. Which we can reduce to 1 bit of randomness.
Oh, we could reduce it to 1 bit of randomness even easier. If the number is not 0 or 1, roll again until you get a 0 or 1.
Yeah, we could do that, but then we'll have more loops.
Okay.
So,
okay.
I mean, assuming we want to sort of reduce the calls.
Yeah, you're right. Tell me the algorithm so far.
Okay, so, call ran 5 while it is equal to 4.
Right.
Call ran 5 while it is equal to 4.
Okay, so we do that twice.
We do that twice.
Yeah.
Store the values.
Yep.
Drop the most significant bit, like
Of one of them. Okay.
of one of them. Yeah.
Either one of them.
Okay. Yeah, I was gonna put them together and then drop the most significant bit.
Okay, you can do
but
that.
it doesn't matter.
How do you put them together? What's the operation for that?
You take one of them, shift it over to
Okay, yeah, cool.
or
Exactly.
the other one.
Brilliant. Okay. Yeah. Okay, cool. So let's write this code. You can do it in C. You can do it in any language you want. You can,
Okay.
If you want, I'll boot up Excel here, and you can run it in Excel.
We'll do C. We'll do C.
Okay.
Okay.
The only possible answers after the interview are hire, no hire. There's no such thing as strong hire. Everybody's strong that we want to hire. If they're a weak hire, let's just not hire them, okay? If they're a weak no hire, strong no hire, doesn't even matter. We're not going to hire them. So the only 2 possible answers are hire, no hire. Sometimes you get people who want to say maybe or I don't know, and we don't allow that. If you're about to say maybe, just say no hire, because why bother? The basic rule is it's much, much easier to interview 10 people and find somebody good than to hire 10 people and have to fire 9 of them. In other words, the cost of interviewing is much lower than the cost of trying to get rid of somebody that you hired by mistake. Are there any bugs there?
Yes.
Okay. Now, I got a computer set up for you. I believe it's on the internet. What I want you to do is, using all resources at your disposal,
Yep.
do a little bit of testing and prove to me that this code actually does evenly distribute. We have to reject a lot of good candidates just because we weren't absolutely certain that they were good. but that's a small price to pay rather than the price of having a whole bunch of people messing up your code. It's just not worth it.
I think the reason I really wanted to work at Fog Creek was just that they have a reputation of being such a great place to work for. You know, I felt like I couldn't really go that far wrong. And that it would be a great experience. I would get to work on a lot of things and shipping products. At the end they said, "Well, do you want to work for us?" You know, and then I said, "Yeah, that'd be great."
I go to the University of Waterloo in Waterloo, Canada, and we're known to have the largest co-op program in the world. And what happens is every 4 months, you switch between being in school to being on a paid internship or a co-op. I was just searching through the jobs, as we have, always looking to see which company will hire, and I saw Fog Creek. I didn't even read the whole description stuff. I'd already known, I'd done a bit of research for my first term, and I was like, I want to work there instantly.
There was a group session, or there's a phone call originally, so a 1 hour phone call as a preliminary screen, then a group session for everyone who made it through the phone call, and that same day there were 2 1-hour interviews with 2 of the developers from Fog Creek, and then a week or 10 days later, Joel came to interview the last few candidates. So that was a total of 5 hours worth of interview time. That was the most I'd had from anybody.
Normally a company will only do 1 interview, maybe it's 15, 20 minutes, something like that. Fog Creek did 2 interviews that day, one after another. Each one was an hour long, and they were real interviews. They weren't asking any of the really annoying questions, which we all know what they are. So what did you say your best strengths are? What are your weaknesses? Those type of questions. These aren't actual real questions. You can't test someone's ability on that. So I was really, that's one thing which I love, where the interview itself was actually enjoyable, which was nice. I was given a real problem, and they sat there and helped me through it if I had any questions or anything. But the whole thing about the interview was to see how I went through a problem solving. And I felt that was much more engaging. And honestly, if you're still asking those other type of questions, you're not finding out anything about your interviewers or interviewees. And you really should be asking those type of questions.
When I came to interview, I actually remember being surprised by how not nerdy the people I interviewed with actually acted and looked. And I think that struck me not just because I want to work with cool people who, are good looking, but because the people that work here are not sort of the socially inept nerd stereotype, but they're actually people who can interact with other people, and that's important at a software company because they need to be able to work together on a team and not just be sort of the stereotypical solo hacker who goes off and locks themselves in an office for months on end and then comes out with some piece of code that nobody can ever understand. But instead at Fog Creek, I found that the software developers were very social and able to discuss ideas with one another, able to have intelligent conversations and really function together as a team.
I came in and started answering questions about recursion and hypothetical programming languages at 7 a.m. West Coast time. And I'm not exactly a morning guy, so that was a challenge, but I did it. Also, it really helped that just people are so nice here, and they just have the interview process down pat. Like I met Ben in the morning, and he was very welcoming and very relaxed, and it kind of made the process of answering hard theoretical programming language questions kind of painless and fun.
My first interview was with Brett, who has Brett's a great interviewer, but he is just stone-faced. You start to get a little bit stuck, and he just boom, there's just nothing. And so he asked me for an example about, I think he asked me about an interface that I would change in some software. And for some reason, it was just like gone, everything was gone. And I'm sitting there and I'm starting to sweat, and I'm sort of kind of hoping that he's gonna throw me this lifeline. It's not happening. And I'm sitting there going, oh my God, I look like such a complete moron right now. And I finally had to sort of rescue myself and came up with some example, and it worked out just fine. But in the midst of that interview, I'm sitting there going, that's it. I mean, this was a nice trip to New York. I might as well just pack my stuff and head home, because that's going to be the end of it. I mean, I just got dinged right there. As it turned out, I did all right, in spite of my feeling like I was sucking down gallons of water in the middle of that interview. So that was sort of interesting. I mean, I thought I was just absolutely done.
There's a professor at Yale University, Stanley Eisenstadt, who teaches a course called Systems Programming, and it's considered sort of the weed-out sophomore course in computer science. He gives his students a lot of programming assignments. I think just about every week there's a pretty major programming assignment to be done. And the programming assignments, just to give you an idea, are things like write a command line shell for Unix, write a macro expander, write a compressor using Ziv Lempel Welsh compression. And each of these assignments, he gives them every year. And he gets a whole new batch of CS students that come in and have to work on these problems. They're all done in C. And the students started complaining after a while that this course was just taking way too much time. And a lot of students went to the university administration and said, you know, for Eisenstadt's class, I have to spend like 40 hours a week just on the homework assignments, and that's way, you know, it's disproportional to any other class. And Professor Eisenstadt said to the administration, well, this is true for some students, but other students seem to be able to do these problems in a lot less time. And the administration said to him, well, prove it. And so he started asking the students to keep a log of how much time they spent on each assignment. And so the students, when they do the assignments, are also required to tell him how many hours they spent on that assignment, on that particular programming assignment. And the data set that he got is extremely interesting, because what he has here is a bunch of students, roughly, they're all Yale University students. They're all very smart, right? And they've already sort of pre-selected. And they're all doing the same programming assignments. There's like literally, there may be 30 of them one year, all writing the same Ziv Lempel Welsh compression algorithm. And some of them do it in 4 hours, and some of them do it in 40 hours. And I took a look at his data, did some analysis of it. And one of the interesting things that I found is that there is no correlation between the amount of time they spend on the project and the grade that they get. The grade on the project is also completely objective. It's done by a computer program that runs and tries a bunch of different inputs and checks the outputs and gives you a completely objective grade. So there's no human intervention in what grade you get. And yet, there is no correlation between the quality of the code and how long you spent working on it. And when you think about it, that says something really interesting. It says that even among smart programmers who are able to complete a given amount of work, the amount of time it takes them to do it can vary by an order of 10. And that's pretty extreme. The programmers that I want to hire are the ones that take maybe 1/10 of the time rather than the ones that take 10 times as much time. Think of the iPod. The iPod has a little touch wheel that you turn to change the volume. And when you turn the touch wheel, you hear a little clicking sound, which gives you the confidence. It sort of gives you some feedback that that clicking is actually, that you're actually turning the wheel. Apple kind of went the extra distance. That they provided that clicking, and instead of just playing it through the earphones, which you have plugged in because it's an iPod, they've actually put an extra speaker in that little iPod that does the clicking sound for you. And they've gone to this huge extent because they want that smooth feel to feel clicky. They want that wheel, that when you're touching that smooth wheel, they want it to feel clicky. And they've gone to these kind of great lengths, these great extremes that make the iPod like truly a great design product. You want to hire programmers that can reach the high notes, that can do the really excellent achievements, and that come up with sort of great ideas, that come up with great designs that maybe the average programmers would never come up with in a million years.
I finished school a couple days ago, and I've been driving for about 16 hours out of Chicago. It should have taken me like 10 or 11, but I hit a terrible, terrible storm all the way through Pennsylvania and New Jersey. So it's taken me a little longer than expected. But anyway, now I'm here, and soon enough, I guess I'll be in Brooklyn, Then I'll be able to unload my car full of stuff for the summer. I'm really looking forward to building just real, good, usable software that fills a niche and that normal people actually use, and it's a really high-quality, polished product. And I'm also really looking forward to a place where all my distractions are taken care of, you know? I mean, apparently they have kitchen, lunch, whatever food you need, you know? I'll just be like a happy little monkey with as many bananas as you could possibly eat. It'll be fantastic.
Ein Mädchen oder Weibchen wünscht Papageno sich. O, so ein sanftes Täubchen, wär Seligkeit für mich, wär Seligkeit für mich, wär Seligkeit für mich. Dann schmeckte mir Trinken und Essen, dann könnt ich mit Fürsten mich messen, des Lebens als Weiser mich freuen und wie im Elysium sein. Dann könnt ich mit Fürsten mich messen, des Lebens als Weiser mich freuen und wie im Elysium sein. Im Elysium sein, im Elysium sein.